So for our Chem 110 final talk, we decided to do biodiesel. I'm Jeffrey Fisher.
I'm Connor Gamba.
And I'm Deme Crandall.
So what is biodiesel? Biodiesel is a renewable fuel made from cooking oils, animal fats, and vegetable oils. It is biodegradable and better for the environment compared to regular diesel, which is based off of crude oil. Biodiesel works in engines and has a similar chemical structure to traditional diesel. The key to biodiesel is its chemical structure. It's made up of fatty acid methyl esters. Um, they're created through a process called transesterification, where oils and fats, which are triglycerides, react with a methanol in the presence of a catalyst. During this reaction, the large triglyceride molecules are broken down and new bonds are formed to create biodiesel molecules and a byproduct called glycerol. Similar to traditional diesel, biodiesel is used to ignite engines through compression.
Great. So why does all this matter? So this matters because many traditional diesel fuels contain high amounts of sulfur, which produce air pollution and are harmful to human health. According to Penn State, carbon dioxide emissions from combustion of biodiesel are reduced by about 10% compared to petrodiesel. So clearly you can see from this that biodiesel is much better for the environment than traditional types of diesel. And additionally, this is very advantageous just because of the fact that traditional diesel engines are still able to work with and compatible with biodiesel. And then on top of all this, burning biodiesel also releases significantly lower levels of carbon dioxide, particulate matter, and sulfur oxides, which are very bad for the environment compared to traditional diesel emissions. To go a little more in depth of sulfur oxides specifically, they're very damaging to the environment as they contribute to acid rain when they react with water and oxygen just found in the atmosphere. And then on top of this, they're also very dangerous for human health because they can act as a respiratory irritant when inhaled. The way that this works is that inhaled sulfur dioxide readily reacts with moisture from mucus inside of people to form a sulfurous acid, which is two hydrogen molecules, sulfur, and three oxygen molecules. And that's a severe irritant because it's a very corrosive chemical. And so this is something, like I said, commonly found in diesel fuel that biodiesel kind of avoids or doesn't really have as much of. Um, and so it's a big problem that's avoided then.
Some of the applications of biodiesel is that it's very versatile and can be used across various industries. It can be used for farm equipment, engines, diesel engine vehicles, can be used in industrial heating and power generation. Something really neat about biodiesel is that it can act as a solvent to clean up oil spills due to the fact that it's biodegradable. Some advantages are it reduces greenhouse gases, reduces dependency on fossil fuels as a population. It is biodegradable and it's compatible with existing diesel engines that are already manufactured.
The compounds of vegetable oil are pretty long. We know vegetable oil to be a dense and sticky substance, so it makes sense that the molecule of vegetable oil is also pretty dense. Written out, it looks like this. On the other side, we were adding our methyl or methanol, and this is composed of one carbon, three hydrogen, and the alcohol functional group, OH. One thing that I've learned is that chemists are minimalists. So here we have three different saturation levels of this carbon chain. One in pink, which is labeled R, one in yellow, which we are going to label R prime, and then our third one, which is the least saturated, is R prime prime. Now that we have our reactants, methanol and vegetable oil, we can combine these through heat and sodium hydroxide. This will give us three individual esters or biodiesel. Each one of them contains one carbon, three hydrogen, and one oxygen, but each structure is different when they contain the R, R prime, or R prime prime. Through the process of transesterification, we get the product of biodiesel and propane 1,2,3-triol, or in other words, glycerol. Glycerol is made up from 3 carbon, 8 hydrogen, and 3 oxygen, and it looks like this. Now, I mentioned transesterification before, but how does it exactly work? To put it in simple terms, trans meaning to change, and esters being what we are changing makes it a little bit easier to understand. For example, we have ester A with R and R prime, and our alcohol A with R prime connected to the alcohol functional group. Now, since we can change, we have an equilibrium, and so our ester B will contain R prime and R prime prime, and our alcohol B will become R and our alcohol functional group. Now, going back to our reactants, it's easier to see when we take methanol, the carbon, hydrogen, and the oxygen bond, and we switch that with the vegetable oils C3O. And this is what we call transesterification. Now, to make it visually sound, we have vegetable oil and methanol written already in colors. Now, for our products of the three esters, we are going to be taking the CH3O from methanol, and it will become our ethanols. And we are going to add that with the R, R prime, and R prime prime from vegetable oil, creating our three esters, or biodiesel. That with the original compound of vegetable oil plus the hydrogen from methanol, we can create our 1,2,3 propane. This helps us visualize where each element goes to and the new compounds are built.
Okay, and so now that you see how biodiesel is made, we're going to go into the chemical reaction of one of the most common uses for biodiesel, which is in engines. So as Jeffrey mentioned, biodiesel ignites through compression ignition in engines. The way that this process works is we have a depiction of the chemical reaction right here. So biodiesel and oxygen combine to create carbon dioxide and water as byproducts. This picture right here kind of shows the step-by-step process of this occurring in an engine. So essentially, oxygen enters a engine cylinder, and a piston right here moves up, and that compresses the oxygen molecules. And that compression of oxygen molecules heats them up because the oxygen molecules are closer together, and because of that, they're more frequently colliding with one another, heating up the actual cylinder in this engine. And then biodiesel is injected into this, and because of the high temperature from the oxygen molecules, the biodiesel is ignited, which causes this piston to push down, creating power into the drive shaft of the vehicle. And then this basically combustion process converts the oxygen molecules and the biodiesel into the byproducts that we have, which are carbon dioxide and water, which is exited through the exhaust valve of the engine. And that's really it. So now that we've mentioned all the different applications for biodiesel and what it's used for, how it's made and why it's important, hopefully everyone's been able to learn a little bit about the value in it. And yeah, thank you.
Thank you.
Thank you.